Hi, everybody. Thanks for joining us today. My name is Angela, and with me is Connor, and we'll be talking about CRD-ifying Cloud Foundry for Kubernetes. So in the next 12 minutes or so, we're going to talk about what the current state of CF4Kates is, and then explore why exactly we think CRDs is the future of the project. We'll then look at what's happening now in relation to CRDs, as well as look at the near future at what could happen with integration for CRDs. So hopefully you are all able to attend the previous session where Eric and Andrew did a deep dive into CF4Kates. But if not, we're going to do a quick refresher on what exactly this project is. So CF4Kates is a deployment artifact that allows us to run Cloud Foundry on top of Kubernetes. This project has two main goals. One is to be more Kubernetes native, so leveraging Kubernetes native features for Cloud Foundry. And then second, it looks to build on top of Kubernetes ecosystem projects, such as Istio, kpack, Fluentd, and Envoy, so that we're able to focus on really some of the key CF features rather than additional extensibility and benefits that each of these different projects provides. So when we think about the components that are running on a Kubernetes cluster when you deploy CF4Kates, we can think of it in sort of three main buckets. First and foremost, the Cloud Foundry components that we've historically known and loved, such as CAPI and UAA. Secondly, some additional components that are either Kubernetes native or created to be a bridge between the historical CF components and the underlying Kubernetes infrastructure. So Irene, kpack, and Istio as some examples. And then lastly, you have your application workloads themselves running on top of the cluster. Now, this works, it's great. It allows us to deploy Cloud Foundry on top of Kubernetes. But when we think back to the goal of CF4Kates, we want to zero in on the idea of being Kubernetes native. And we notice that when we look at this diagram, there are some components that are historical parts of Cloud Foundry that have really been lifted and shifted from VMs to pods running on Kubernetes. And so to really try to embrace the philosophy of being Kubernetes native, it begs us to ask the question, what would it look like for these different components and the Cloud Foundry architecture as a whole to be more Kubernetes native? And this is where CRDs come into play. So CRDs represent custom resource definitions, which are a Kubernetes resource that allows you to define a custom resource. A custom resource is an extension of the Kubernetes API. So essentially, custom resource definitions are a way for us to establish API contracts using Kubernetes as the data store and API. And so now that we've level set on what both CF4Kates and CRDs are, we'll now go and take a deeper dive into why exactly we think that CRDs are going to be a critical part of the future of CF4Kates. And with that, I'll hand it over to Connor.
Hi. First, I'd like to talk a little bit about declarative platform management, which one might think of as CF administrator interfaces with Kubectl. For a long time, CF administrators have wanted more declarative interfaces for managing their platforms. And while Bosch offered some of those, it's much easier for us to offer them in a more Kubernetes native way. So traditionally, we'll talk here about buildpack management, but traditionally, when an administrator wants to add a new buildpack to the platform, they'll run cf create buildpack Node.js, and the CF CLI will go and talk to the Cloud Controller API, upload some packages to the blob store, and make an entry within CCDB. But parts of this workflow aren't very declarative. For example, when you run, if you want to change your auto detect order for your build packs, you need to run cf update build pack with a position argument. But the ordering of them depends largely on what else is in that list. And so the interface is not very declarative. With CRDs, we start to break all of these different steps down. We don't need to just talk to the CF API, but instead we can upload our cloud native build pack package directly to a container registry. and then apply a new kpack builder to the Kubernetes API in order to declare a whole new list of ordered build packs. That builder can then reference the image that we just uploaded to the registry previously in its YAML. And just like that, we've created a whole new completely declarative interface for the management of buildpack and buildpacks in their auto detection order. When pushing, this builder gets referenced by the kpack image that the Cloud Controller API creates. So we push an app, the Cloud Controller hands the package off to a blob store, the Kubernetes API will then accept an image from the Cloud Controller, and the image itself, another kpack CRD, can reference the builder that the administrator created earlier, and use the build packs in the registry that it points to build the package that was uploaded to the platform by CF push. Beyond platform management, there's also great hope for creating new declarative interfaces for app management. And these would look like CF app developer interface with kubectl. However, there's some complexity here. In particular, authorization is very difficult to manage within this space. Administrator interfaces are easier because often CF administrators have access to the Kubernetes platforms that they're running on, but CF app developers don't necessarily. And so this makes it so that particularly things that are writable, things that we might want to modify are hard and dangerous to implement. We probably won't be seeing any of them very soon. Things that might be like CF space manifests as a CRD or CF apps as a CRD are very exciting and things that we'd love to build. But first we have to figure out how to get app developers authorized to the platform, the Kubernetes platform, that is. However, we already have a lot of readable realities. And for staging and building, that means things like kpack images and custom builders and these things that we've been talking about, pods that they create. For runtime compute, for apps, this means the actual stateful sets and pods created by Irene in the process of starting to run an app. And for network ingress, this means the route CRD. And for operators and other people who have access to the Kubernetes API, all of these things can already be read, accessed, their statuses examined, their errors seen, their configuration, and so on, inspected. And I think that's pretty exciting. And with that, I'll hand it off to Angela to talk a little bit more about extensibility.
Great. So already we see a lot of great possibilities in regards to CRDs with both platform and application developers being able to manage their different components declaratively. But in addition, we can also see CRDs as an entry point to making the CF ecosystem more extensible. So let's take one example to understand what exactly we mean by extensibility with respects to CRDs. So in this case, we're going to look at the example of ingress routing. Currently in CF for K8s, when you create a route, so you run CF create route, you'll be reaching out to CAPI, which is actually already doing the work to create a route custom resource in the K8s API. The networking team has done a lot of work in regards to not only creating the route custom resource definition, but also the corresponding route controller that's able to watch for these route custom resources and based on the creation of them, create Istio configuration. Istio is also running on our cluster and is able to see this configuration and update the Envoy to know where exactly to forward requests to, so that when you try to actually make a connection to your application, you go through the Envoy and are successfully ingress routed to the application. Now, in this workflow, we can pinpoint certain components, such as the route controller, Istio, and Envoy, and ask ourselves a very basic question. Could we swap these out for another ingress solution? That is, the route custom resource is the contract between CAPI and any networking team. And instead, you simply have to program a new controller that will create custom resources for some other Ingress project. So one such option would be in the future swapping out these three components to instead be using Contour. And this updated route controller that's being swapped out will be watching for route CRs and instead creating Contour config instead of Istio configuration. In addition to extensibility, we can also see that using custom resources as the mechanism for understanding what's happening in Cloud Foundry for K8s also exposes a lot of benefits with Kubernetes tooling. So the Kubernetes community has done a lot of work in creating some great tools for both developers and operators to understand what's going on in a Kubernetes cluster. And so there's a rich ecosystem that we can take advantage of if we assume that we have the current state of the world in the Kubernetes cluster as custom resource definitions. So we don't have enough time to take a look at demoing some of these tools, but there's a variety of web GUIs such as Octane, in addition to CLI tools such as K9s that provide a lot of great features to understanding what's going on in your system.
So today, and in early versions of CF8s, we are already utilizing CRDs in several ways, as we've been over. Particularly for builds, kpack has images, custom builders, and builds. And for network ingress, routes do a great job of representing what we can and cannot route traffic to.
In addition to what we currently have available as custom resources, there's also a lot of work going on right now to provide a variety of additional CF resources as CRDs in the near future. Some of these include work that CAPI is doing to represent droplets as custom resources in Cloud Foundry. Services teams are looking at what it would mean to actually be having services represented as custom resource definitions, and in fact are looking at even using existing projects running on Kubernetes, such as service catalog, as a means of doing so. And then lastly, Irene has started to look at what it would mean to shift the contract between itself and CAPI to be one using CRDs instead of the current model where we have an OPI layer to deal with LRPs. And with that, thank you so much for attending our session. We're more than happy to be answering any questions live.